the role of different parts of a DC motor. So what kind of things they do? First, we'll talk about armature. It does the main key thing that a DC motor does. That is converting what? Converting, yes, electrical energy into mechanical energy. Right? That's the role of an armature. How does it do that? We'll be understanding it shortly. Next is your magnet. So obviously it's providing the magnetic field. Okay, so it's from right to left. In our case, it can be anyhow. And this is a simple motor. They are of course complicated and different design motors. And the magnetic field is something else altogether over there. Then we have the brush and the ring that we'll be talking in time. So first let's look at how does this happen. So to begin our discussion, we have to look into what will happen when we switch on the circuit. So we have the current going through P1, R1 across AB, BC, CD, and back to R2, B2 and the negative terminal. Right, this is the direction of the flow of current. So now we know the direction of the magnet, we know the direction of the current. We want to know how this rotates. So what is the law which will help us link all of this? Yes, our Fleming's left hand rule. So let's apply that. I hope you guys remember. If not, please revise that and come down. So we have the length AB. Current is going away from us. So we have the magnetic field from right to left. So that's our magnetic field. This is our length AB na. So let me, right, it's not erasing only. That's our current. So, okay, let's think in this dimension. That is, we have to see to that the current, that is the middle finger, is pointing away from us. The index finger is pointing to the left. Are you guys doing it? Right, away and this left. So now the thumb is by default will point up. Right, so this is this length of AB gets pushed up. Right, now let's talk about CD. So the length CD, the current is coming down. Then we have the magnetic field right to left. Then what else? Then we're looking at the push. So for that, again, think in this dimension, right? So this is on horizontal plane. So you have to turn your hand a bit, twist your hand a bit. So your middle finger is pointing towards back, right? The magnetic field is to the left. So the index finger is towards the left. So thumb by default is pointing, yes, downward. Make sense? So this is up, this is down. What happens? This entire system will turn clockwise. Make sense? See, this dotted line, let me make that clear. So I've made that dotted line, but what does it serve? That talks about the axis of rotation. Okay, that is the length around which this entire system rotates. So that's the stick that you guys see in the DC motor. Right? So next time when you guys watch that video, see, please observe that. So this is our entire working. Okay, this is up and this is down. Oh yeah, length BC. So along the length BC, we have the current moving from left to right, but the magnetic field is from right to left. So what will happen? They don't affect each other. So there's no force acted upon this. So here the force happens to be 0 Newton. So it's not going to play any role in terms of getting pushed or pulled. Right? So now what you guys can do is observe the video, the experiment again. watch what exactly will rotate. Is the brush and the ring rotating or not? Observe that, and then we'll continue with the functions that are displayed by different parts of a DC motor.